Welcome back. In this video, we're going to look at the equilibrium rule. Equilibrium is when something is equal. If you are in equilibrium, the forces that are acting upon you are equal. That is the same as static. If something is static, it's not moving. So if you're standing on the floor, you have a weight that's pushing you on the floor. And if you're not falling through the floor, then you're standing still, then what must be happening is that the floor is exerting an equal push up to your shoes so that you are not moving. That's called stasis, and that's equilibrium. The rule is that all the forces equal zero. Whatever forces are going up and down will cancel each other out, and whatever forces are going east and west is also going to cancel each other out. So two strong men that are playing arm wrestling, one is putting a force to the right, the other is putting a force to the left, and they're canceling out each other's force until one of them has a higher force, and then the hand will move. That's how it works. It's no longer in equilibrium, and it would be moving. Okay. Now you can have a force, you can have a moving object that's in equilibrium as long as there's no forces that are acting that are not balanced. So equilibrium really is not motion so much. It's forces. The forces, the acting that's pushing or pulling on an object are balanced. They're in equal. Whatever is north and south are equal. Whatever is east and west is equal, and everything cancels. All right, so we're going to look at a painter standing on a board. A painter stands in the middle of a board suspended by the ends of two vertical ropes. So I'm just going to draw it. Here's a board. Okay, I've got a vertical rope here, a vertical rope here, and I've got a painter here. Okay, he's standing there. So the painter and the board are in mechanical equilibrium. Okay, mechanics is that motion that we were talking about, something moving. So if it's in equilibrium, then the forces acting on the board and the painter are equal to each other. Okay, so it says the tension in each rope is 350 newtons. So I've got 350 newtons acting up in this direction. I've got 350 newtons acting up in this direction. And if this weighed nothing, if the board were weightless and the man were weightless, the tension in this line would actually lift the board up. You can imagine something being hoisted up. If you have more force going up, then it goes up. Okay, but it's not going up. It said he was in equilibrium. That means the forces are balanced. That means, let's just do it here, the painter and the board together has a weight, and that weight is going to be equal to the tension in the line. So the tension of each is the forces in the strings, and the weight is pushing down, and if he's not moving and the boards are not crashing, then they're equal to each other. So 350 and 350 acting up is equal to one force, we'll just call it 1, acting down. So this would simply be the double of 350. So I have 700 newtons acting down. That 700 is the weight of the board and the painter at the same time. Okay, so it shows you here what information are given. Tension in the rope, that's T1. Tension in the other rope, that's T2. The weight of the painter is weight 1. And the weight of the board is weight 2. Okay, so here's what's set up. Now they're going to ask you a question. The painter's weight is 550 newtons. Okay, so 700 newtons includes the weight of the painter plus the weight of the board. And we see that the painter's weight and the board's weight equals 700. Okay, so we know the painter's weight is 550 newtons. So 550 plus what is 700. Okay, so that's how we're going to find it out. 550 plus 50 would be 600. So this is going to be 150. You could do that by subtraction, 700 minus 550, and you'll get that the board weighs 150 newtons. Okay, now let's see how they've shown you how to do it very systematically. We don't know W2. We know T1, that's going up. We know T2 going down. We know W1 going down, that's the painter's mass, but we don't know W2 going down, okay? We know that the forces are equal. This is sum. The sum of the forces are all equal to 0. So all the upward forces are balanced by all the downward forces. And so you're going to say the sum of the forces are going to be, okay, you can do it one way or the other. You could say, you could put all the upward forces on one side and all the downward forces on the other side because they're equal. I kind of like to do that. So let's do all the upward forces. Upward forces is T1 plus T2. So we have T1 plus T2. The downward forces are the weight of the painter, W1, and the weight of the board, W2. And I have these are equal to each other. W1 plus W2 equals T1 plus T2. So the sum of the forces, that's sigma, that's a Greek letter sigma, sum of the forces are going to be equal to T1 plus T2 minus W1 minus W2. And so you fill in what you know. This is 350. This is also 350. Okay, this is 550. And this is 0 because the sum of the forces are equal to 0. And the only thing left has to be, so when you bring all this over, you could say W2 equals 350 plus 350 minus 550, and you'll get W2 equals 150 newtons. Okay, so this is as systematic as you could get. This was my version, which I think is much simpler. You're looking for ups and downs being equal to each other, and the picture helps you. Okay, so stop the video and see if you can do number 1, and I'll come and meet you in a second. All right, we're back. The 3 vertical ropes hold up a board that weighs 180 newtons. All right, so I'm going to draw a picture. Here's a board. I've got 3 vertical ropes. The board weighs 180 newtons. Now, if you are in equilibrium, then all the forces acting down are equal to all the forces acting up. Okay, it's not moving up, it's not moving down. That means that you have 3 forces acting in the tension of those strings. Those ropes have tension in them, they're tight, and that tension is a force. Okay, if they didn't have a force, they would break. Or if the 180 were higher than if these were made out of thread or whatever, it would break. So they will have tension in them, and that is a force acting up, and the weight is a force acting down. We're going to see that it's balanced, that F, the sigma F, the summation of forces are going to be equal 0 if it's in equilibrium. That means that this is going to be tension 1, this will be tension 2, this will be tension 3, and all of them are summing, so that is acting up and this is acting down, so I'm going to put them on equal sides, or opposite sides. T1 plus T2 plus T3 equals 180 newtons, okay? And they are all going to be the same. They're 3 strands and they're going to be the same because there's no reason one would have more tension than the other, because the weight is going to be equally distributed among in the board. It's a board of, arguably would be, the density would all be the same or whatever. Okay, so we're going to just say these are all the same. So I'm just going to say 3t equals 180. Divide by 3, and you're going to see that t equals, what's your guess? 3 times 60 is 180. So this is going to be 60 newtons, and each of these will have 60 newtons acting up. All right? So look at number 2, and I'll come back in a minute. All right, we're back. We also have a board, and we have a painter standing on that board. And it says he's supported by 2 vertical ropes. And the weight of the board, okay, so the board only, this is the board, is 180 newtons. It's acting down. The painter weighs 700 newtons. Okay, so he's also acting down. So this is 700 newtons. What's the total of the forces acting down? You have 700 Newton man and a 180 Newton board. Can you see that they're going to add together? They're both acting in the same direction. So this is going to be 880. So we have going down, we have 880 going down. That means you have a total of 880 acting up. They're balanced. That's what force equals 0 means. But how many strands do you have? You have 2 suspending ropes. That means that the 880 are going to be divided equally among those 2 ropes. And so what are the tension in each rope? T2 is going to be equal to 440 newtons, and T1 is also equal to 440 newtons. Okay? How did you do? Did you do well? Did your table earn any points? I hope so.